Right, today in geometry, we're going to look at Envision section 10.3, which deals with chords. We're going to look at how our chords related to their central angles and to intercepted arcs. So number one, it says, why is segment RS congruent to segment UT? So let's write down everything that we know. I know that SQ, QR, QT, and UQ are all congruent, right? So I could say that SQ is congruent to QR. I could say that TQ is congruent to UQ because they are all radii, right? I know that angle Q, right? So angle SQR congruent to angle TQU because they are vertical angles. Now I have triangle SQR congruent to triangle TQU by SAS. Therefore, I could say RS congruent to UT by CPCTC, right? Let's see on number two. Why is angle BAC congruent to angle DAE? Okay, well, so I start out, they told me that BC was congruent to DE. I know that AB, AC, AD, AE, I know all of those are congruent because they're radius. So AC congruent to AB, AD congruent to AE. So this one was given. These are all radii. So now I could say triangle ABC congruent to triangle AED by side, side, side. Therefore, angle BAC would be congruent to angle DAE by CPCTC again. All right, so now we have a whole bunch of theorems today to talk about. The very first theorem, if two chords in a circle or in congruent circles are congruent, then their central angles are congruent. So in this picture, if I know that this chord NM and PQ, so if NM is congruent to PQ, then I know that their angles are congruent. Then angle NTM is congruent to angle PTQ. Okay? The converse of that, if two central angles are congruent, then their chords are congruent. So if I started out knowing that those angles were congruent, then I would know that the segments were congruent. The next theorem we want to talk about, if two arcs in a circle or in congruent circles are congruent, then their chords are congruent. So if this arc and this arc are congruent, so if arc NM is congruent to arc PQ, then segment NM is congruent to segment PQ. The converse of that, if two chords in a circle or in congruent circles are congruent, so if NM is congruent to PQ, then I know their arcs are congruent. Arc NM congruent to arc PQ. Theorem 10.5 tells me if two chords are equidistant from the center of a circle or the centers of the congruent circles, then they are congruent. Okay? So SF and SE both show me that they are congruent. So if SF is congruent to SE, then I know that those chords that they're touching, AB is congruent to DC, because they are both the same distance from the center. Then the converse of that is also congruent. So if two chords in a circle or in congruent circles are congruent, so if they started out telling me that AB was congruent to DC, then I would know that SF was congruent to SE, that they were the same distance apart from the center. All right, one more theorem, and then we're going to start working some problems. So theorem 10.6, if a diameter is perpendicular to a chord, then it bisects the chord. So in our picture, if my diameter all the way across CD is perpendicular to a chord, so chord AB. Then it bisected that chord, so then I know AE is congruent to BE. And then the converse, if a diameter bisects a chord, then it's perpendicular. So if AE is congruent to BE and CD is a diameter, then I know CD is perpendicular to AB. 10.7, the perpendicular bisector of a chord contains the center of the circle. So the perpendicular bisector, right, of the chord, so CD and AB are perpendicular, right? So CD is perpendicular to AB. Therefore, point S, the center is on CD, okay? The chord contains the center. All right, let's look at some examples. So number one, if the measure of arc AB equals 110, so arc AB, what is the measure of arc BC? I see this chord is 9, this chord is 9. I have two congruent chords, so that means that my arcs are congruent. So if AB is 110 degrees, BC is also 110 degrees. Now number two, the measure of A to C is 150. Find the measure of AB. Well, I know that those are both the same. So if I do 360 minus 150, I get 210. But since these have to be the same, cut that in half, and I get 105. Let's go to this number 3 right here. In circle R, chord AB is congruent to chord CD, so that means that my arc lengths are congruent. Arc AB is 108, find arc CD, also 108. Okay. Now let's look at 3, 4, and 5 over here. Find the measure of the indicated arc in the diagram. I have the diameter is perpendicular to the chord, so that tells me that that chord got cut in half. So they want me to find arc CD. I know that they are equal to each other, so here I would just say 9x equals 80 minus x. So I get 10x equals 80, so x equals 8, so plug that in, so 9 times 8, 72 degrees. So this is 72 degrees. So now it says find arc DE. Well, DE, remember we said they were congruent, it's also 72 degrees. Find arc CE, well, that's 72 plus 72, so that is 144 degrees. Down here to number 6. In this diagram, circle C, QR equals ST, which equals 16. So those are equal to each other. Find C to U, right? If my chords are equal, that means that they're equidistant, right? So 2x equals 5x minus 9. Subtract 5x, so I get negative 3x equals negative 9. Divide by negative 3, x equals 3. So C to U is equal to 2 times x, which is 3, 6. So we get CU equals 6 units. Okay. Last page of notes. Number 7, in the diagram, circle P, PV equals PW. QR equals 2x plus 6, ST equals 3x minus 1. Find QR. They are the same distance from the center, so that means that they are also congruent. So 2x plus 6 equals 3x minus 1. Add 1 to both sides, so I get 7 equals x. So QR, they tell me that was 2 times x plus 6. So 14 plus 6, so Q to R is 20 units. All right, last picture. Use circle P. The measure of arc AB, so A to B, that is 43 degrees. AC equals DF, okay, so this and this are congruent, so that means those are congruent. Find each measure. So DF is the very first thing that they want me to find, okay? So I know that that and that are the same since it was perpendicular. So if that's 43, that's 43. This has the same arc measure as this. So DF is going to be 40, sorry, D to F. I was finding the arc measure. D to F. Let me just erase that. DF. All the way across, right? So that's the chord. This chord got cut in half, so that side's 2. Remember, this is the same because my chords are congruent there. So 2 plus 2, 4. Now, the measure of arc AC, okay, so that's going to be 43 plus 43, 86 degrees. F to H, we have that marked as 2. Measure of arc DE, well, this has to be the same as this, 43 degrees. AC all the way across is 4. And the measure of arc DF, again, that's going to be 43 plus 43, 86 degrees. All right, so that takes care of section 10.3, our chords. Remember that next week we will be taking our chapter 10 test. We're halfway down with chapter 10.